be covering the topic simultaneous equations on graphs. So first of all, what we need to understand is whenever we are solving equations simultaneously, what we are doing behind the scenes is basically we are drawing out the graphs of each equation and then solving for their points of intersection. So for example, in this particular example, we have the equation 2x plus 3y equals 8 and 3x minus y equals 23. Now they want us to solve this simultaneously. Let's say in GCC we would have done it like solve this simultaneously, right? Whenever we're doing this, we're solving them simultaneously. Obviously you would know that we rearrange for y equals, and then we put that into this equation y and get an x value and one y value. So these are linear equations, right? So when we are solving them, we get one x value and one y value, right? And we get one x and one y value. And what is that x and y value? That is basically the graphs of each being drawing out, and we're finding the point of intersection. And that x and y coordinate is what we find solving algebraically. But what we are essentially doing is we're drawing out the graphs and we are finding the points of intersection. So using that concept that the solution to simultaneous equations is the points of intersection, in linear equation, when there are two straight lines and they intersect, they only ever gonna intersect at one point. They can't intersect at more than one point. So when we're solving linear equations, there will be only one solution. However, when we have a linear equation solving with a quadratic, now there could be three scenarios. The first scenario is that the linear equation is intersecting with our quadratic graph, the parabola, at 2 points. In that case, we're gonna have two real solutions, meaning we're gonna have two pair of x and y coordinates, which, as you would know from GCC, that's why we get two x values and two y values, because there are 2 points of intersection. And in that case, when we basically solve the question, we gonna if they say find these x and y values, and I'll show you an exam question. Just remember that there are two solutions when the intersection is at 2 points. Now, if obviously using the same concept, if it's intersecting at 1 point, in this scenario there will be only one real solution. And if they're not intersecting at all, there is not gonna be any solution, no real solutions. And now we get in the topic of discriminant, where basically when we are gonna solve these simultaneously, we gonna get we can get this b squared minus 4ac, and that will be greater than 0, and you'll understand what I'm talking about in a minute when I do the question. So the line with the equation, so that's our linear graph, so 2x plus 1 meets the curve with the equation 2kx squared plus 2y plus k minus 2 at exactly 1 point, right? So first of all, we know that they're meeting, so we're gonna solve them simultaneously. And this exactly 1 point of a part of the question tells us that there is going to be one real solution, because they're only intersecting at 1 point, right? So now let's solve it. We have this our line equation, and we have our quadratic graph equation, and I know it's a quadratic graph because it's x to the power of 2. Now I solve this by putting the y value of that into the quadratic equation, and I get this final quadratic equation. Now in normally GCC we have numbers over here, but now we're working with unknowns, we're working with algebra. Now how to proceed forward? Now remember, if you would have covered the topic of discriminant, you would know that when the quadratic graph intersects with the x-axis at 1 point, we say that the discriminant is equal to 0. And it's the similar scenario here. The discriminant, because there's only one intersection, the discriminant is going to be exactly equals to 0, which I do over here. So what is the discriminant? It's b squared minus 4ac, right? So, and there is one intersection. So we're going to take this quadratic equation and we're gonna use the discriminant and we're gonna set it equal to 0. Now b over here is, so let's write the quadratic values. B equals 4, a equals k because that's the coefficient of x squared, and c equals k, right? Now we can use this to uh, solve our discriminant equation right here. So we get 4 squared, so b squared minus 4ac, and when I get that, I get an equation minus 4k squared equals minus 4k squared plus 16, and when I solve that, I get k equals 2, which, as you would remember, that's what the question asks us. Given that the k is a positive constant, find the value of k. And how did we do that? We couldn't proceed forward with the normal steps as we do in GCSE. We need to gain the formula, the concept of discriminant here, and say because it meets at exactly 1 point, we know that our discriminant is going to be equal to 0. Let's say there was no solution, it did not meet with the graph. In that case, we would set our discriminant less than 0 because it's going to be a negative number, remember, and when there's no real solutions. And if in the question it asks us there are two real solutions, we would have set our discriminant greater than 0 and solve for a range. But for this one, because we had one in this specific question, we had exactly 1 point, we could set the discriminant equals to 0 and then solve for k. And yeah, that's the topic of simultaneous equations covered. Thank you.